Greetings and welcome to the Introduction to Astronomy. In this episode of New Discoveries in Astronomy, we will talk about how a shattered asteroid may have bombarded Earth and the Moon about 800 million years ago. So let's get started. How can scientists reconstruct an ancient asteroid bombardment when almost all of the evidence on Earth has disappeared? About 800 million years ago, something may have dramatically increased the number of asteroid impacts throughout the inner solar system. Today, Earth's active geology has erased most of those traces of those impacts. But another world has preserved the evidence. Researchers believe the story began in the main asteroid belt between Mars and Jupiter. A large asteroid known as the Eulalia parent body suffered a catastrophic collision and broke apart. What made this event especially important was its location. The asteroid lay beside a region of space called the 3-to-1 resonance with Jupiter, a gravitational gateway that can redirect asteroids out of the main belt and into the inner solar system. Rather than remaining safely in the asteroid belt, many fragments escaped onto new orbits that crossed the paths of the terrestrial planets. Computer simulations show that this resonance scattered asteroid fragments toward Earth, the Moon, Mars, and other rocky worlds. The bombardment was not a single event. Some fragments entered the resonance immediately after the collision, while others drifted into it over tens of millions of years through a process called the Yarkovsky effect, a tiny force produced as asteroids absorb sunlight and slowly re-radiate that energy as heat. The result may have been an extended period of increased impacts lasting more than 100 million years. But how do scientists know this bombardment really happened? The answer comes from comparing Earth with the Moon. Unlike Earth, the Moon has no weather, flowing water, or active plate tectonics to erase ancient craters. Its surface preserves a long history of impacts stretching back billions of years. Researchers compared the ages of the large lunar craters with computer models of the Eulalia breakup. The timing matched remarkably well, suggesting that this ancient asteroid family could have produced the impact surge recorded on the Moon. Earth was almost certainly struck as well. In fact, because Earth is larger and has stronger gravity, it would have experienced even more impacts than the Moon. Yet very little physical evidence remains because our planet constantly reshapes its surface. This study demonstrates how scientists can use one world to reconstruct the history of another. By reading the impact record preserved on the Moon, they can investigate events that Earth's own geology has long since hidden. One of the remarkable things about astronomy is that evidence is often preserved in unexpected places. The Moon is more than Earth's nearest neighbor. It is a geological archive that has quietly recorded events our own planet can no longer remember. By learning how to interpret that record, scientists are uncovering chapters of the solar system history that would otherwise be lost forever. So that concludes our discussion on a shattered asteroid may have bombarded Earth 800 million years ago. We'll be back again next time for another new discovery in astronomy. So until then, have a great day, everyone, and I will see you in class.